Okay, solve the system of equations. So the first thing I think I want to do is let's start by getting rid of this xy term. So I'm going to multiply this bottom equation by -2. So that will give us 4xy plus 3y squared equals -9 over -4xy minus 2y squared equals +10. So if I add those, I'll get positive y squared is equal to 1. So y is equal to plus or minus 1. Okay, and then I can eliminate the y squared term here by multiplying the bottom part by 3. If I multiply this bottom part by -3 now, then I'll get 4xy plus 3y squared equals -9, and I'll get -6xy minus -3y squared is equal to +15. So if I add those, I'll get -2xy is equal to 6. So I can divide by -2 and I'll get xy is equal to -3. And so if y is equal to 1, then x is equal to -3, and if y is equal to -1, x is equal to +3. So the pairs that we get are 3, -1, and 1, -3. So those are the xy pairs that we get. So we get this pair and this pair as our solutions. The next one, use the system of equations to solve the following. An electronic sign for a grocery store is in the shape of a rectangle. The perimeter of the sign is 72 feet and the area is 320 feet. So I know the perimeter is going to be length times width, or length plus width plus length plus width. So 2L plus 2W equals 72, and then the area is 320. So L times W equals 320. So I can divide by L, say. So I'll get 2L plus 2 times, and then I have W is 320 over L equals 72. I can multiply everything through by L to simplify a little bit. So I get 2L squared plus, what's 320 times 2? 640 equals 72L. And then I have a quadratic. And I think I can divide everything by 2. So I'll get L squared minus 72, or sorry, what's 72 divided by 2? 36. L plus 320. Okay, and then I can do quadratic formula on that. Okay, and so 36 squared minus 4 times 320 is square root of 16. So let's see, so square root of 16 is 4, so I get L is equal to 36 plus 4, which is 40 over 2, or 36 minus 4, which is 32 over 2. So that's L is equal to 20 or 16. So, and then I know, and then so we can just pick one, and if L is 20, then the width is going to be 320 over L, which is 320 over 20, which is 16. So if we wanted the length to be longer than the width, then we'll have 20 by 16. Okay, and so given the basic function that, what transformations would yield the graph of that? So, so this 5 here means I'm going to the right by 5. This 3 here means I'm going down 3. And this 2 here is a vertical stretch by 2. The next one, given the piecewise function, evaluate the following. N of 0. So if I want to evaluate n of 0, 0 is in this interval here. So I'm going to use this function x. So n of 0 is just 0. N of 2. So 2 is in this interval here. So I'm going to use this function. So n of 2 is going to be negative 2 squared plus 4, which is negative of 4 plus 4, which is 0. And then the next one, n of negative 2. Negative 2 is in this interval here. So I'm going to use that function. So n of negative 2 is negative 4. And then last one, n of 5. Well, 5 is, again, in this one because 5 is greater than 2. So I'm going to use this function here. So I'll have negative of 5 squared plus 4. So that's negative 25 plus 4, which is negative 21. Next one, determine the relative maximum min of the following. So if I look at A, I can see that I have 3 points here where I have these kind of relative maxes and mins. So relative min so we can say relative mins occur at the point negative 2, negative 4, and at the point 2, negative 4. And we have a relative max at the point 0, 0. On this one, I have a relative max. It's also the absolute max on this particular problem, but anyway, it's at negative 1, 2. Then it says use interval notation to write the intervals on which the function is increasing, decreasing, or constant. So the function is decreasing. So if I move from left to right, I want to look at where the function is going down. So the function is going down there. And so I'm looking really at the interval of x values in which it's decreasing. So from negative 3 to negative 2. So this is an interval of x values. In other words, it means negative 3 less than x less than negative 2. So this is an interval of x values. Okay, and then an interval in which it's constant, so we can see it stays constant across this interval, and that's from x equal negative 2 to x equal positive 2. So in other words, that means negative 2 less than x less than 2. So either way, we can write that. And increasing, again, increasing from 2 to infinity. So in other words, x greater than 2. The function is increasing. Okay, given those functions, find the following. F plus g of 3. So that's going to be f of 3 plus g of 3. So if I plug 3 into the function f, it's 2 times 3, which is 6. And g of 3, if I plug 3 in here, I have 3 times 3 is 9 plus 1 is 10. So the answer is 16 on that one. B, g minus f of negative 2. So that's going to be g of negative 2 minus f of negative 2. So what is g of negative 2? If I plug in negative 2 into the function g, 3 times negative 2 is negative 6 plus 1 is negative 5 minus, and if I plug in negative 2 to f, I get negative 4. So negative 5 minus negative 4 is negative 5 plus 4, which is negative 1. F times g of 4, that's f of 4 times g of 4. And if I plug 4 into f, that's 8. 2 times 4 is 8. And I want to multiply that by g of 4, which is 3 times 4 is 12, plus 1 is 13. So 8 times 13 is 104. And the next one, f divided by g of negative 1. So f of negative 1 divided by g of negative 1. So if I plug negative 1 into f, I'll get 2 times negative 1, which is negative 2. And if I plug negative 1 into g, I get 3 times negative 1. That's negative 3 plus 1 is negative 2. So negative 2 divided by negative 2 is 1. Construct and simplify the difference quotient for the following functions. Okay, so for this function, I want to do f of x plus h minus f of x over h. So f of x plus h minus f of x over h. For this function, I'll have 8 times x plus h minus 5 minus, and I'll put a bracket here, 8x minus 5. So that's my f of x divided by h. So this gives me 8x plus 8h minus 5 minus 8x. And then when I distribute this minus into both of those things, I'm going to get a plus 5 over h. So if I see here, I have a positive 8x and a negative 8x, so those two add to 0. A negative 5 and a positive 5, so those two add to 0. So what I'm left with on top is an 8h over h. So that's just 8. For this one here, I'll go over here. So if I do f of x plus h minus f of x over h, when I plug x plus h in for x here, I'll get 3 times x plus h squared minus 5 times x plus h plus 4 minus 3x squared minus 5x plus 4. All of that divided by h. So let's see here. When I get this, I'll have 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 4 minus 3x squared plus 5x minus 4 all over h. And we should see some common factors. So the 3x squared minus 3x squared, negative 5x plus 5x, negative 4 plus 4. So all of those terms go away. I'm left with 6xh plus 3h squared minus 5h all over h. And what I notice is that each of these terms has an h in it. And so I can factor out the h. And I'll be left with 6x plus 3h minus 5. And I can divide that by h. And so then h divided by h is 1. So those h's go away, and I'm just left with 6x plus 3h minus 5. So that's my final answer. The next one, I have f and g. I want to find f composed with g and g composed with f. So f composed with g of x can be rewritten as, as f of g of x. So that's f of g of x. And remember, g of x is 2x plus 3. So I want to plug in 2x plus 3 for x in the function f. So it'll be 2x plus 3 squared minus 4 times 2x plus 3. Okay, so that's F composed with G. Now for G composed with F, we'll do it in green. We did that in red. And so for G composed with F of X, that's G of F of X. That's G of, what's F of X? X squared plus 4x, oh, minus 4x. Okay, and if I plug that into G, it's going to be 2 times x squared minus 4x plus 3. So that's G composed with F. Okay, number 40. It says to write a variation model using K as the constant for each of the following. Okay, so for A, it says the volume of a rectangular solid varies jointly as the length and width of the solid. So V equals sum K times LW. The time travel T is inversely proportional, and the time of travel T is inversely proportional to the rate of travel R. So that means T is equal to K over R. So inversely means it's 1 over. And then the circumference of a circle varies directly as its radius R. So C equals KR. Okay. Last one, the area of a picture projected on a wall varies directly as the square of the distance from the projector to the wall. So area equals sum K times S. Okay, the area of the picture, square of the distance, D squared. If a 15-foot distance produces a 36 square foot picture, what is the area of the picture when the projection is moved 25 feet? Okay, so we will say 15 foot is the distance. We're going to plug that in. So 36 equals K times 15 squared. And then I can do 36 divided by 15 squared is 0.16. Okay, and so then it says, what is the area of a picture when the projection unit is moved 25 feet from the wall? So we expect it to be bigger. So A equals 0.16 times 25 squared. So that's 100. So 100 square feet. Okay. If the projected image is 144 square feet, how far is the projector from the wall? So we're going to plug in 144 for our area. And we'll still use the same K. So we'll do 144 divided by 0.16. And then I want to do the square root of that. So square root of 900. So I get 900 equals D squared. Square root of 900 is 30. 30, and that's measured in feet.